Thank you very much. Good afternoon, everyone. Thank you for joining today's webinar, Bringing Energy Efficiency and Indoor Air Quality to Your School through EPA's Energy Savings Plus Health Guidelines. My name is Michelle Carreri, and I'm with the U.S. Environmental Protection Agency's Indoor Environments Division. Today's webinar will feature two great presenters with years of experience in the area of energy efficiency and IAQ management. Our first speaker is Kudret Utebe. He works for the Cadmus Group, and he serves as the Deputy Program Manager for a contract that provides analytical, technical, and outreach support for EPA's Energy Star commercial, institutional, and industrial sector. Kudret has more than 20 years of experience in education, research, energy, science, and technology. For the past 13 years, he's worked closely with school districts to evaluate building energy performance and assist school districts who are integrating indoor air quality into their energy efficiency projects. Our second speaker is Dave Berger. He's with Des Moines Public Schools, Energy and Environmentalist Specialist. In his role, he's responsible for the day-to-day implementation of the district's environmental health, safety, and energy efficiency programs. The district serves more than 32,000 students, 5,000 employees, and it manages 71 facilities covering more than 5.8 million square feet of space. That's a big district. Today's webinar will include an introduction to the Energy Savings Plus Health Guidance, an accompanying check generator, information on best practices, procedures, policies, and key principles that you need to understand to effectively protect indoor air quality while increasing energy efficiency during your renovation projects. You'll also hear an in-depth case study from Des Moines Public Schools, who is utilizing the guidelines while implementing energy efficiency measures in several of their district schools while protecting and improving indoor air quality and occupant health. You'll get an information on a variety of EPA resources on indoor air quality and energy efficiency, and finally we'll end with a Q&A session. EPA's Indoor Environments Division has developed a comprehensive guidance for schools from cradle to grave, starting with new construction. Our Indoor Air Quality Design Tools for Schools guidance provides both detailed guidance as well as links to other information, resources to help you design and build new schools. Next up is our Indoor Air Quality Tools for Schools technical guidance. This guidance comprehensively covers all of your day-to-day maintenance and operations of your school facilities. It's actually our oldest of our guidance, dating back to 1994 when the first kit was released to the public. The kit is available online, but recently it's also now available via a new mobile app. We hope that you'll take advantage of the mobile app. And then finally, our newest guidance is the Energy Savings Plus Health Indoor Air Quality Guidelines for School Building Upgrades. This guidance equips schools with tools to integrate indoor air quality protections into school energy efficiency retrofit and other building upgrade projects. The Energy Savings Plus Health Guidance is really the backbone of our work to ensure that the major capital investments schools are making on energy upgrades and renovation projects protect the health, productivity of students and staff by promoting, not compromising, indoor air quality. We applied all the school districts that are out there that are integrating indoor air quality into their energy efficiency projects. Kudret, I'll turn it over to you now.
Thank you so much, Michelle, for the great introduction. Hello, everyone. My name is Kudret Utebe with Cadmus Group. I work in support of EPA's Energy Star program as well as EPA's Indoor Environments Division. I would like to start with an initial why focus on buildings topic. As you may already know, energy is a controllable cost and is a significant percentage of our operating costs and reduces operating profit. In fact, energy is the second cost in school districts after employee salaries. Any cost that you shift from the energy cost improve your bottom line. According to EPA, about 1/3 of the energy consumed in our commercial industrial buildings go to waste. And again, according to EPA Energy Star program, the 10% of reduction is possible with little or no cost. There are over 17,000 K-12 districts in the United States, and they are spending about $8 billion annually on energy. As I mentioned before, 1/3 of that energy goes to waste, and least efficient schools are responsible for that waste. EPA did a study on Energy Star certified schools, and they found out that Energy Star schools cost about 40 cents per square foot less to operate than the average school in the United States. Let's start with the Energy Savings Plus Health Guide. Why EPA produced this guide? As you can see on the screen, the main purpose is to protect and improve indoor environmental quality in our school buildings during building upgrades, including energy efficiency retrofits. This guide also helps you with your indoor air quality protection, indoor air quality management plans, energy management plans, and occupant safety during your retrofits. Energy retrofits and other building upgrades can disturb some existing contaminants that are available in your school buildings that are known to cause health problems. Some of these contaminants have specific regulatory requirements, such as asbestos and lead, that must be followed. Care must always be taken to ensure that these activities, the retrofit activities, do not cause any issues with the already installed equipment, such as venting of combustion appliances or increase occupant exposure to combustion byproducts. You may already have some moisture problems in your buildings, and we need to make sure that any activity, retrofit activity, should not create new ones or increase the already in place moisture problems. When we talk about mold and moisture, I would like to remind everyone that EPA created a great mold remediation guide that is available for download at epa.gov/IAQ/schools. Please feel free to download a copy of that. We have already talked about some of these, but I would like to touch the last point here that I didn't touch before. The higher ventilation rates are associated with improved student performance and health. There are some studies mentioned in the guide that talks about the correlation between higher test scores and lower absenteeism. Please take a look at the introduction section of the guide to find the links to these studies. Here's a nice study from Department of Energy completed back in 2014. If you look at the bar graph on the right-hand side, this study concluded that our permanent school buildings, this is not about our modular buildings that we add to our schools, but this is just for the permanent buildings. If you look at the list of systems that we use in our school buildings, somewhere between 15 to 30% of the equipment that we use in our school buildings will need some kind of a retrofit in the very near future. And when we close a look at the list, as you can see, most of the items that need to be retrofitted very soon are about energy efficiency as well as indoor environmental quality. Another study done by Lawrence Berkeley National Lab and Association of Energy Service Companies show that back between 2008 and 2011, schools spent about $5 billion for retrofits in their buildings. And the study foresees that by 2020, that amount could double and even maybe triple, going up to about $15 billion. When we go into more detail in the study, in 2008, about 3/4, 75% of the revenue went directly into energy efficiency related activities. And that didn't really change much in 2011. There was only about 1% difference. Close to 75% of that revenue in 2011 also went to energy efficiency. And when we look into the sectors using this money. K-12 schools share about 20% of that revenue in 2011, a little bit slightly down from 2008 figures. And the study concluded that about 70% of the 2011 revenue came from energy savings performance-based contracts. Now, it's obvious that schools are spending a lot of money on energy efficiency retrofits. So that brings us back to how we take care of indoor environmental quality in our school buildings during those retrofits. And going back to the guide itself, the Energy Savings Plus Health Guide was designed for some primary audience that you see on the screen, including school facility managers, risk managers, building operators, administrators, and especially for anyone who is working in that building, including architects, construction contractors, sustainability coordinators, and of course for students and parents. Basically, any stakeholder in a school building is the intended audience. The guide itself has 4 main sections. The first section is the introduction and how to use the guide. The second section is shows assessment protocols and recommended actions based on type of retrofits. Section 3 has 3 appendices. I will be briefly giving you some information on each of them. And lastly, Section 4 has a master verification checklist that will help you identify the type of indoor air quality measures you may need to consider during building upgrade projects. The Section 1, Introduction, has basic information about how to use the guide, and we have great information in there that talks about health case and business case of why you should be considering indoor air quality measures during any retrofit you have in your school buildings. It will also give you some information about what the guide is about and how to use it. As you can see on the screen, the section will have basically 3 columns. The first column will talk about assessment protocols for each priority issue, each of the 23 priority issues discussed. And there will be another column for minimum actions to help you understand what type of deficiencies you may need to correct for different retrofits, and make sure that your activities do not cause new or worsen currently available IAQ issues in your buildings. And the last column will be about expanded actions. These are basically actions that EPA recommends for you to take action on when it's feasible financially. Under introduction, we have a table 1. There's a snapshot of this table 1 on your screen. I picked the lighting, but you will find other retrofit types in the table 1. You will be seeing a list in the next slide. The first column in this table will show the type of retrofit activity. Second column will show potential indoor air quality and health and safety risks. And the last column will tell you which priority issues from the guide you should be considering or thinking about during that specific retrofit activity. The upgrade activities under Table 1 are lighting, building envelope upgrades, HVAC system upgrades, material selection, and you could also use this guide during your normal operations and maintenance activities. Putting the guide to use. My recommendation is for the first-time users and those less familiar with the guide itself and its concepts to use the entire guide as a comprehensive resource. After gaining some familiarity with the guide, you can streamline the process for specific projects using the checklist generator. The checklist generator is a Microsoft Excel tool. It works with macros, so if you end up using that, you need to enable your macros on your computer. It will help you, it's actually a great time-saving tool. It will help you create customized checklists for your specific retrofit activity. Here are the 23 priority issues that talk about environmental tobacco smoke, HVAC equipment, outdoor air ventilation, exhaust ventilation, building safety for children and other occupants, protecting IAQ during construction, and priority issue number 23 is the job site safety. Let's take a closer look at some of the priority issues, starting with the project planning and integrated design. The first case shows an example of the look and feel of the guide in section 2. This is not feasible to do for every priority issue in this presentation, but I assure you that they'll look pretty much the same. In this specific example, we did not have any expanded actions from EPA, so that last column on the right-hand side is intentionally blank. Each priority issue will talk about the assessment protocols in the first column, things like what you should be doing in the initial project planning stages or integrated design stages, such as collecting feedback from school stakeholders, such as school nurses, custodians, even sometimes students or principals. And the next column will provide the minimum actions you may want to take to achieve your goal, and then look at the last column for sure. If you think feasible, we strongly recommend that you implement any of the expanded actions provided in the guide. And just as a reminder, in the Section 3 appendices, the first appendix is about project planning as well. I'll be giving you a little bit more detail on that later. Priority issue number 3 is about mold and moisture control. Moisture control is an important consideration for schools, actually for any building type, and requires careful attention during building upgrades. The moisture and mold could come from a lot of different places. Interestingly, we depend on water throughout our lives, but a lot of damage could also come from it through, for example, plumbing leaks, leakage through the building envelope, leakage from the roof, or any space with high humidity rates. On the screen at the bottom, you see 3 pictures. The first one, the mold is growing on the wall from the condensation of room air. But the mold is not always visible as this one. Sometimes it will be hidden behind your wallboards, and sometimes it will be on the ceiling through the leaks, for example, from rainwater. Priority issue number 7 talks about radon. Radon is the second leading cause of lung cancer in the United States, and elevated radon levels have been measured in schools. It's important to test for radon and take action to lower elevated radon levels. In the Iowa, Des Moines Public Schools have some serious issues with radon, and Dave Berger, our guest speaker today, will be talking about what they're doing to prevent issues that stem from radon in their schools. Priority issue number 9 is about vehicle exhaust. When you have a school, you need to have those school buses, and parents bring their kids to the school building every morning and picking them up in the afternoon. And there will be some complaints in regards to the vehicle exhaust. There are some laws in regards to vehicle exhaust in our school areas. If there are any complaints from your students or any staff from the school, make sure that you investigate and address those complaints immediately. Some complaints could be from air leaks from the parking structures, or even from outdoor air intakes through the HVAC equipment. We need to have some strict idling zones and seal openings. When school buses drop students, they drop them very close to our school entrances. So we need to have good sealing in place in those entrance areas. Priority issue number 18 is about our HVAC systems. When you're doing any work with the HVAC system, make sure that you assess the equipment condition as a whole from the very beginning. Ensure that existing systems are well maintained and operating properly and as intended. As you see on the screen, you may, if you don't maintain your HVAC equipment as a whole, you may have issues such as the very dirty filter on the bottom left. That filter looks like it has not been changed for several months. And make sure that you control all filters and any blockage to intakes of the HVAC equipment ducts. Priority issue number 19 will talk about outdoor air ventilation. Most states have policies in place to mandate meeting the requirements of ASHRAE standard 62.1. Depending on our state, the year could change, but most states will request 2013 or after. For schools, if I remember correctly, you need to pump, for example, 15 CFM into your school buildings per student. So the guide will provide you with information in regards to what type of measures you should be taking when you are doing any building upgrades that relates or touches anyway to your outdoor air ventilation system. And priority issue number 22, and just a reminder again, they will be talking about some of these priority issues and how they use the guide and which priority issues they had to follow during their retrofit processes, including the priority issue number 22, which is about protecting indoor air quality during construction. The guide will provide you with information and links for guidelines that you need to follow during construction, including the SMACNA indoor air quality guidelines for occupied buildings under construction. SMACNA, by the way, is Sheet Metal and Air Conditioning Contractors National Association. Excuse me. As you can see on the bottom right corner of your slide, during the construction, we need to make sure that if you're working in one space and there are students or staff working in another, the ducts must be protected properly, so any construction material does not contaminate our system and take that bad air, if you will, into spaces where our students study or your staff work. Section 3 is about appendices. The first appendix is about project planning and developing a project team. Appendix B provides a lot of great information about communication and education during retrofits. And then Appendix C provides information about the safety of the workers doing the work in your school buildings. I would like to emphasize that all of these three appendices are provided here because of their importance. You have to have a great project planning, and you have to have all the project team members in place before you start any work in your buildings. And most of you probably have experienced that great communication and education of the staff and workers is especially important. You may do all the right things, but if you do not communicate that work to all stakeholders, you may still run into some issues and may end up re-explaining yourself. And the master verification checklist contains a list of all assessment protocols, minimum actions and expanded actions listed under Section 2 of the guide. To use and to verify performance assessments and actions and to keep track of the progress. The master verification checklist is about 15 pages long, and it's formatted for easy use. And I should have a snapshot. This one is a snapshot of the master verification checklist in PDF form. It goes through all assessment protocols and action items, provides you with 2 columns for completed work, and then allows you to take notes during the retrofit for each priority issue. The master verification checklist is somewhat replicated in the customized checklist generator, which is an Excel tool that I mentioned, and it can be downloaded from EPA website. I will have the links or URLs to both guides at the end of the slide set. The checklist generator looks like this. On the right-hand side, you will see the retrofit types, including building assessments, project planning, building envelopes, HVAC system, material selection, and operations and maintenance. Based on your retrofit type and your needs, all you need to do is check the checkbox next to the retrofit type you're dealing with. And if you want full language for each assessment protocol and minimum actions and expanded actions, check this checkbox as well and click the button called Click to Generate Report. This action may take a little bit of time depending on how many checkboxes you have. For the top 2 I selected here, it took more than 30 seconds, for example, but if you select 10-15, it may take up to a minute. It's a relatively quick checklist generator. This is the checklist, the printable checklist, and how it looks like in Excel. As you can see, it's very similar to the master verification checklist. The only difference is this one is tailored towards the assessments, project planning and commissioning, and the lighting upgrades checks that I have in place here. And this is the printable protocols and actions. This is the full language for each assessment protocol and recommended action mentioned in the guide itself. If you have any questions, the help tab on the right-hand side could help you find some of those answers. And with that, I would like to pass the microphone back to our guest speaker, Dave Berger from Des Moines Public Schools. Dave?
Thanks, Kudret. I appreciate it. So anyway, my name is Dave Berger. I'm with Des Moines Public Schools in Des Moines, Iowa. First of all, thanks to Kudret. Thank you to Michelle and all the folks at EPA for giving us the opportunity to talk a little bit today. Just want to kind of go over briefly on the things I want to touch on today. A little bit about who we are, where we started, and how we ended up where we're at today in terms of our capital improvement programming, what we've done in our buildings in some general senses, a little bit about our relationship with Energy Star, and then how we are utilizing the Energy Savings Plus Health guidelines, both in projects that have been completed, how we're using it in some of the things we're doing today, as well as on a daily basis, how we're implementing some of these guidance points and some of the information contained in there. So a little bit about who we are. Michelle indicated earlier, we are actually the largest school district in the state of Iowa. At the present time, we're actually just a little bit over 6 million square feet. We did add one facility this year and did a little bit of expansion. There's a breakdown of what our district consists of in terms of the types of facilities that we have. We're an older school district. We are an urban school district with an average age of about 65 years. So we have a variety of challenges. Our oldest building was built just before the turn of the 20th century, and our newest building was actually constructed just within the last year and a half or so. So we kind of run across the entire range, and we see a lot of different things that we have to contend with because of that. Again, as Michelle alluded to, we're about 33,000 students, right at about 5,000 staff, and we're actually one of the largest employers in the city of Des Moines. Kind of taking a look back and what we've done, the school district embarked on what we now refer to as Students First in 1999. Since that time, we have been able to essentially touch every single one of our buildings in one way or another. We are completing our last full facility renovation this year. We do have an elementary school that was sort of mothballed for a few years. That is getting a full renovation this year. That will then be converted into a combination administrative / alternative education program facility. But by and large, we have been able to go through and do major mechanical renovations, physical renovations, finishes, things like that in every building. So it's been an expensive process for us to get there. We're just shy of $500 million that we have committed to this program since the implementation of this initiative, and we feel that it's been money well spent for a lot of different reasons. We do fund this out of a variety of different sources. We do have a statewide penny fund that we receive funding directly from the state for. We also have what we refer to as a PEBBLE fund, or a physical plant and equipment levy. That is actually based off of property taxes. And then we have a general fund as well that we do a lot of our day-to-day from. But sort of where we're at now with our program is we're operating on 5-year revolving programs. We're trying to look 5 years ahead, 10 years ahead, and determine what's most appropriate for us to address over the course of the next 5 years or so. Des Moines Schools and Energy Star. We first really started our involvement with Energy Star back in about 2008. We've been fortunate enough to I guess you would say, sort of reap some of the benefits and the rewards of our involvement with Energy Star. We're very proud of the fact that we're a 5-time partner for energy management and sustained excellence the last 3 years. And we also have been recognized for the Climate Communications Award the last 3 years. Energy Star is something we take very, very seriously here. We believe in the program. We've seen the positive outcomes of the program. And it's a program that for us has been very easy to go in and discuss with staff, students, parents, the stakeholders in our buildings, because it's a very recognizable thing. So for us, it's been a real win-win in a lot of different ways. Part of that, our involvement with Energy Star. Every year, if you're not familiar, Energy Star has what they refer to as the National Building Competition. We've been fortunate enough in our Battle of the Buildings competitions. We have had several buildings that have finished very well over the last couple of years in the energy savings department. I didn't put up anything in here about this most recent competition that ended, but we were fortunate enough to have a couple of buildings this past year in the National Building Challenge that showed greater than 20% energy reduction. We had one of our water management or conservation teams that finished in 5th place overall amongst teams, and we had a couple of individual facilities that finished in the top 10 for water conservation. So this is one of those things that's exciting for us to do. We enjoy doing it. Our buildings enjoy doing it. And it's one of those things that allows us to kind of promote some healthy competition amongst our facilities. Here's just a real brief overview of sort of where we've been and where we're at now with our involvement with Energy Star and how our buildings are doing. This just shows our elementary, middle, and high schools. Obviously, I don't have administrative facilities and whatnot on here. But we feel like we've shown some pretty good gains. Source EUIs is kBTU per square foot. We've had some decent reductions in there, approximately 20% on our elementaries and high schools, 30% on middle schools. And our Energy Star scores have come up a long way since we first started to baseline our buildings back in 08, 09, somewhere in there. This is just a snapshot kind of showing energy expenditures from a financial standpoint for us, as well as this also shows where we're at from the standpoint of providing climate control in our buildings. Back when we started in earnest with Energy Star, about 65% of our classrooms were air conditioned. We're up to just shy of 100% of our spaces are air conditioned now, and actually with the end of this summer and some projects we have ongoing, I think we're actually going to reach 100%. But I think this graph shows pretty well that you can implement energy efficiency programs that will both bring occupant comfort, will save you money. We started out at about just shy of $6 million per year for energy expenditures. This year to date, the 3.4 million that I'm showing there, that is a year to date. So that's essentially through the end of May. Our fiscal year ends at the end of June. So we're anticipating this year that we will be down once again in our expenditures for total energy costs, which we're extremely positive about, as well as the orange boxes show that our average Energy Star score has increased by 43 points over the course of that time, which again is something we're very proud of. To kind of get into the meat of things a little bit, I want to talk a little bit about a couple of facilities that have recently been renovated. And I discussed a little bit before in earlier presentations, but now that we're a little ways into sort of the post-renovation phase, I think we can discuss these in a little bit more detail and a little bit more earnestly. Smouse Opportunity School and Ruby Van Meter are two of our facilities, and these are facilities that serve, for us, sort of more unique populations. Smouse Opportunity is a pre-K through 8th grade facility, primarily for children with physical and developmental educational disabilities. Ruby Van Meter is the high school equivalent of that. We have a lot of kids that begin their education at Smouse, and once they become freshmen in high school, they transition over to Van Meter. There is another building off to the left there. You can hopefully see a little running track. That's Callanan Middle School, one of our larger middle schools. But I want to focus on Smouse and Van Meter a little bit. Both of these were buildings that were renovated this past summer, and largely because of the populations we serve there, they kind of hold a special place for a lot of us around here. Here's a brief little snapshot of Smouse. Smouse was built in 1931. It's an extremely unique building. It's probably architecturally one of our neatest buildings. Kind of a little aside about it, it was actually constructed by a local physician, gentleman by the name of Dr. Smouse. He built it specifically for kids with developmental disabilities because at the time it wasn't socially acceptable for these kids to be in the, I guess you'd say, the mainstream classroom. So this facility was built specifically with these children in mind. About 54,000 square feet. The renovation activities that we completed this past year, it did receive full mechanical upgrades. We did a full lighting retrofit in this building. One of the things we did in both Smouse and Van Meter with our lighting, we did tunable lighting in all of our classrooms. The teachers and the educators in those spaces have the ability to adjust not just light levels up and down from a dimming standpoint, but they can also range or go through an entire range of colors on those lights from about 2,700 degrees Kelvin up to about 6,500 degrees Kelvin. Gives them a little bit more flexibility in terms of being able to help manage their space and be able to provide an environment that's a little bit more suitable for whatever specific activity it is that they have in hand at a moment. Historically, we did have some indoor air quality issues there. We had some persistent water intrusion issues, both structurally. We had some tuck pointing issues to do. A few little roofing issues. Windows in this building were replaced just a few years ago, so we did not touch the windows in this building at this time. Given the age of the building, there were asbestos-containing materials that we had to contend with. We did have some lead-based paints. And down here, one of the things that, and I'll show this on Van Meter as well, is our baseline Energy Star score on this building was a 34. And at the present time, it's a 56, and I will have to admit we're scratching our heads a little bit on this one, given the nature of the renovation activities we completed, as well as a few other things I'll discuss when we get to Van Meter. But we fully anticipate that there are quite a few more Energy Star score points to squeeze out of this building. We're just sort of in the process of trying to determine exactly where they're at, because we know they're there. Down below here, this is just kind of a brief synopsis of some of the priority issues that we specifically tried to address out of the Energy Savings Plus Health Guide. As Kudert discussed earlier, there are 23 priority issues identified. This is just a sampling of those that we pulled out as we were going through the design process to make sure that we were addressing. I'm not going to go into each one of these in detail, but what we have found from our experience is that for the types of projects that we're completing and from other folks that we're, fortunate enough to discuss this program with, we're finding that a lot of these are very consistent from one project to another. Here's a summary for Van Meter. Again, very similar in terms of how we went about addressing this building mechanically and from a retrofit standpoint. The water-to-water VRF system that we used. You'll notice down here our baseline energy score on this building was a 16, and we just actually cracked 75 here a couple of weeks ago, and we see that continuing to go up. One of the reasons I mentioned that we're scratching our heads a little bit on the Smouth project from an efficiency standpoint, we did something a little bit different with these two facilities in that we have a shared power plant between these two buildings. Our cooling tower, boilers, things like that are over in the Ruby Van Meter facility. Everything is then piped over to Smouth, so we're essentially serving two buildings out of the mechanical plant at Van Meter, yet Van Meter is performing a little bit differently than Smouth is. So that's where we have some things to look at. Again, very similar indoor air quality issues that we wanted to address as we were going through this building. Again, we had some historical water intrusion issues. Most of the issues there at Van Meter when it comes to water intrusion were actually related to historical mechanical modifications, changes to relief dampers on the roof, things like that over time broke down a little bit where we were getting water into the building. Again, we did have some asbestos-containing materials to address, lead-based paints. And if you were to look at the priority issues that we evaluated at Van Meter compared to Smouth, virtually the exact same list. This is just kind of a brief little table that goes over some of the different project components or the items that we addressed during these renovations and what we perceive as the advantage from an indoor air quality standpoint. I mentioned the asbestos-containing materials. We did complete abatement projects in both buildings. Van Meter was, essentially a full building abatement project. Smouth, we did not take every single piece of material out of that building, but the advantage there, we know that we have removed a potential respiratory hazard from the facility by doing that. Also at that time, with Smouth in particular, gave us an opportunity to go through, do some additional looking around, digging, and address any maintenance type activities we would need to do on known ACM. The conversion to LED lighting, obviously, I think everybody knows LED is a positive from an energy efficiency standpoint, but it allows us to get out of the business of having to manage special wastes that are generated by needing to dispose of fluorescent light bulbs. We're anticipating that the amount of contact time we'll have with those fixtures will be much less disruption of building materials around those fixtures, things like that. So we see that as a real win for reducing potential hazard exposures, primarily from needing to deal with bulbs and ballasts, things like that. Concrete or polished concrete flooring, this is something that we have really taken and run with in the last 8-10 years. We have found that polished concrete flooring from a maintenance standpoint is significantly easier to contend with than vinyl floor tiles. It's certainly easier to deal with than carpeting, and we avoid a lot of the issues that we run into with carpeted space from allergens and moisture, trapping moisture and things like that. We don't polish every single floor, but shared spaces, corridors, those spaces where we can, we have found that it's been a very positive item for us. We actually polish our floors to an extremely fine grit, to the point where we try and avoid the use of sealers and whatnot on our polished concrete. It has significantly reduced the amount of cleaning materials, polishing, sealing materials, things like that we're using. So that's been a positive for us, and we've found that our building occupants really appreciate it and they like the appearance. Waterproofing, we have some water intrusion issues there. As Cooter addressed, the fact we obviously want to keep the water out of our buildings. HVAC equipment, both of these projects were primarily focused around major mechanical retrofits. The list here, just a brief list of those things that we would gain from an indoor quality or air quality standpoint. We found there's a real positive to be able to kind of start from ground zero with mechanical systems and be able to maintain that system moving forward. The other thing is our building management system. I'll touch on this a little bit later, but we do have a relatively robust building management system that's integrated throughout all of the district's 72 facilities. From an indoor air quality standpoint, it really allows us to drill down to individual spaces and, one, be able to evaluate what's going on in those spaces from a temperature, humidity, carbon dioxide standpoint, so that we can see the trends of what's going on in those spaces. And it also gives us the opportunity to, in many cases, make changes on the fly so that we can better suit the occupants' needs and comfort and health. Just a couple of quick photos that go over the various priority issues that were addressed. In these two projects, priority 3, the moisture and mold, there's some water impacted fiberglass insulation in that photo to the left. The asbestos picture there on the right, that's actually the old cooling tower at Van Meter. That's an old transite cooling tower that was abated and removed for disposal. HVAC equipment, this is actually a photo of the shared mechanical plant at Van Meter. Units in the front there, those are actually the portions of the variable refrigerant flow system that is serving that building. It's tough to see. We have a couple of small high-efficiency boilers in the background. And then something that has been important to us for quite a long time is the issue of maintaining integrity of new materials as they go into buildings during construction. The blue plastic on the end of the ductwork, that is something that we have insisted upon through our specifications and whatnot for a long time, is that we expect our contractors to be providing us with materials even before they leave their shop. They need to be brought to our facility and installed in such a way that when everything goes live, we don't have excessive dust and debris. We don't have anything introduced into those systems that we do not want into the building. So that's something we try and pay particular attention to is how those new systems are maintained during construction. This is one of the things that Kudraт and I discussed a little bit as we were getting into the preparation of today's presentation was really starting to drill down and look at some quantitative data on what's going on in our buildings post-renovation in terms of occupant comfort and occupant health and things like that. Essentially what this slide represents is if all of the data that's available is a swimming pool, this is maybe a teardropper full. Essentially what we did is we went in and started looking at absenteeism rates for these two buildings in particular. The ADA percentage, that's average daily attendance, given that we just renovated those buildings recently, we had a pretty small window to work from in terms of post-renovation time frame. So what we did is we just went back and we took a look at average daily attendance for staff and students. Staff is listed as TBD or to be determined because we're still trying to figure out exactly how to best pull some data out of some of our systems. But anyway, we looked at September of this past year, 2015, through the end of March. And what we did is we went and we just simply looked at, okay, what were average daily attendance rates for that time period compared to the previous year's period. Again, this is a very, very small sample. We do not necessarily say that this is indicative of anything one way or another. This is sort of our starting point, and for a district our size, we have an awful lot of folks managing an awful lot of data. And what we wanted to do is we sort of wanted to get the ball rolling with these two facilities to figure out what data do we have, who do we get it from, how do we all work together to pull it together in a concise way that it can be beneficial for us when we look at how our projects are impacting building occupants. We know there's lots of factors involved here, but anyway, prior to renovation, that previous school year, we saw about a 92.5% average daily attendance rate at Smouse. A little bit higher, about a percentage point and a half. I guess you'll say better attendance rate post-construction. Van Meter, we had a little bit of a dip down there. Now, again, there are many, many factors involved here. We're not saying that this is specifically related to the renovation project. What we're finding, though, is as we're starting to compile this data, we're discovering we have an awful lot of information we can look at. So our intent is to essentially take this approach, roll this out to other buildings within the district, ideally every single facility at some point in the district, and go back and start looking at what information do we have pre and post construction, especially given we've touched all of our buildings. What can we go in and start looking at in these buildings to help us define whether or not our renovation projects are potentially having any impact on building occupants. One thing about these two buildings, again, we have unique populations in these buildings. We do have some students that have in some cases pretty extreme health challenges. So whether or not we're seeing some factors there, we're not 100% certain. We'll be updating this as time goes on, and certainly it's something that if we have an opportunity to share sort of where we get with that in the future, we would love to. This slide here is a slide that what we did is we sat down with our nursing director for the district, and we asked what type of information we would be able to obtain from them for various periods of time, generic information as it relates to the types of concerns that our nurses in our buildings are seeing and what they're hearing about. And we think that this is potentially going to be an extremely valuable tool for us to be able to help identify some patterns, be able to help identify sort of what's going on in our facilities in a way that maybe we don't necessarily hear about on a daily basis, because maybe it's not related to, the rooms are hot or the rooms are cold, or something feels stuffy, or somebody sees something on a wall. What we did, we went in, and our nursing department has a pretty exhaustive list of different concern areas that their nurses can record individual complaints against. So what we did is we went through the list, picked out 8 or so here that we felt would be potentially related to or would have some type of correlation to an indoor air quality condition. So again, we looked at September to March of 2014 to 15, and then the post-renovation period in both of these buildings. And we just started to go through, and again, it's a very, very small data set. We'll be looking at more, but we just wanted to see, do we have any improvements? Do we have anything that stands out that would indicate that maybe our nurses are seeing something going on in these buildings that we should then roll back and start looking at and wonder if, did we do something to the building that's potentially causing an occupant some type of concern? So we came through and looked at this list. Again, we'll be expanding on this, but this is the list that we had for Smiles. Again, some issues with some of our kids were potentially, and obviously there's lots of factors that go into this, but there may be some of these things that are not specifically related to their experiences just in their school environment. But we wanted to look at these, and we think that as we build on this data set, this is something that will be extremely useful. Did the same thing for Van Meter. Again, in some areas we saw some decreases, some areas we saw some slight increases. We're going to continue to monitor this, and we'll build on this as we go. Something else that we did is, and goes back to the fact this is an extremely small data set. As we move forward with this, one of the things we want to do is we want to take a look at, as we build our data sets for information that's being provided by our nursing staff, we think that there's also some importance to be able to take a look at what's going on in the larger population as a whole, what's going on at the community level that might also potentially be driving some of the nursing concerns or the medical concerns that we're getting from our buildings. So this is something we'll continue to add on, and what we did here is we just simply took a look at total number of concerns amongst all of those categories that we just viewed within our buildings. So the blue line represents total concerns, Ruby Van Meter and Smouse. Want to make sure I have that correct there. So that's Ruby Van Meter and Smouse for the period prior to construction, compared to the yellow line, which is actually total reported influenza-like illnesses for the Health and Human Services Region 7, which includes the state of Iowa. We can drill down a little bit farther. We do have access to information from both the state of Iowa and the county, Polk County, that Des Moines resides within. But this is something that we feel that as we move on and as we put more data into these data sets, we're going to want to be looking at these things to see if we can be pulling in some data from outside that might help us understand why we're seeing some of the things going on in the buildings that we are. This is post-renovation. Again, pretty small data set. We'll continue to look at this as time goes on. Just a real brief summary of a few of the efficiency IAQ initiatives or programs that we have been working on. And these are really more sort of global for us as a district. LED lighting has been sort of a major focus for us. We've made a real push in the last couple of years to exclusively transition to the use of LED lighting. With 6 million square feet, we don't have the ability to just go out and say we're going to change every light fixture in the district. We have made a concerted effort, though. We've transitioned all of our exterior lighting to LED. Every project we do moving forward is spec'd out as LED. We're not doing fluorescent anymore. And then we do have an ongoing project where we're trying to chip away at 3-4 buildings at a time, sort of continuously to go through and upgrade our lighting, transition all of our interior lighting within existing facilities to LED. I've already kind of touched on concrete flooring. Our mechanical systems, we've tried to be conscientious about the way that we utilize mechanical systems within our facilities, and we try and make them appropriate, make those choices be appropriate to a given facility and where it's located, things like that. The photo down here in the bottom right is actually of the installation of a horizontal geothermal system. 42 of our 72 facilities are actually operating off of geothermal systems now. And from an efficiency standpoint, it has been extremely positive for us. We've seen phenomenal reductions in energy consumption. As such, reductions in the financial impact on total energy costs. But what we also see with those systems is it allows us to utilize technologies that also provide us with a little more freedom of controlling our indoor air quality. Solar hot water is something we're dabbling in. We're starting to utilize that a little bit to supplement some of our hot water needs, in particular in our elementary schools. We are also at the present time looking at utilizing hot water to supplement the geothermal loops in our buildings, in particular during our cold months. If we can use essentially the free hot water generated by the sun to elevate our loop temperatures in our buildings, we're going to see some pretty significant cost savings and energy efficiency savings in these buildings. At least that's what we're feeling right now. And also some radon smart design, and I'll discuss the radon issue here in just a minute. How we're utilizing and what we see the relationship with the Energy Savings Plus Health program. Like Kudrat mentioned, it's a phenomenal guide to be able to help you walk through the process of completing work in your buildings. And we see it working hand in hand with those things that we've already been doing. Michelle alluded to some of the other documentation that has been out there for a while, tool for schools, things like that. What we found is that when we first were exposed to the guidance, when we sat down and started looking at how is it conceived and how does it operate and how does that work in conjunction with some of our existing air quality management programs, we found that they dovetailed very, very well. One thing that it does do is it allows us to drill down for our daily activities, our maintenance activities, how we address kind of unique problems, things like that might pop up from an O&M standpoint. One of the big things here also, though, is the fact that I mentioned that here on this note that it's sort of a roadmap. And what we found is that it truly is. It has certainly brought to light a lot of things for us that maybe we were doing, but we knew we could do better. It made us look at some things that maybe we weren't looking at and allowed us to figure out how do we bring those into the flow of project design and implementation and then ultimately facility operation. It has been a good tool for us for communication, not just within our stakeholders, our parents, our staff, our students, the community at large. It's also been for us a fantastic vehicle to be able to discuss with other school districts in the state of Iowa, how we all collectively can do our jobs better. At the end of the day, we're here to educate children, and if there's something that we can all do to help make that process better, it's a phenomenal thing to do. Touching on radon, Kudrat did mention that Iowa is a state that does have some issues with radon, and we definitely do. Anyway, we essentially sit in the middle of the Midwest, upper Midwest, and in the map down there on the bottom left, areas in red are areas that are considered extremely susceptible to the impacts of radon. It is a naturally occurring, odorless, radioactive gas, comes up from the ground, and it's something that has been on everybody's mind in this part of the country for a very long time. We decided that we needed to jump in with both feet back in about 2011 and really implement a district-wide radon management program. We do have a number of facilities where we have test results that have come back greater than the recommended action level of 4.0 picocuries per liter. Radon is something that we've taken seriously enough that we actually have a staff member now here in our facilities department that his primary job is management of our radon program. And we operate on kind of a 5-year revolving program for continuous monitoring with those facilities where there are identified, where we do see radon levels that exceed certain threshold values, whether it's a level of 4 or a level of 2. We do have other facilities that we do some sampling on a more routine basis. But anyway, a little chart here on the right. This is just sort of a flow plan that we came up with several years ago to help direct us as we were going through this. There's been an awful lot of work done by a lot of folks out there within the last couple of years in regards to managing radon. If you're not familiar with like the ANSI ARS guide for measurement of radon in schools and large buildings, there are a lot of tools out there if you're in an area where potentially you're susceptible to dealing with radon. This is a brief little case study of what we have encountered in one of our buildings where we did encounter radon levels above the recommended action level. We started out doing short-term sampling. We did have numbers that were upwards of 12 to 13 picocuries per liter in some spaces. Subsequent long-term testing confirmed that we did have levels above our threshold values. This was a building that was renovated in 2011, and this particular facility, a little bit unique in terms of the mechanical systems we used. We do have a couple of ERVs on this building, energy recovery ventilators. It actually uses an air-to-air variable refrigerant flow system, whereas most of our buildings are water-to-water VRF. This is an air-to-air VRF. But anyway, as we went into this particular building and started to really try and figure out what was going on, one of the things that we started to use in earnest, and we still do, is continuous radon monitors, where we can put instrumentation directly into a space and see what's going on from a radon concentration level at about 15-minute intervals. So what we did is we went in, we put the continuous radon monitors in, and we wanted to see when the building goes into occupied mode prior to arrival of staff and students in the morning, what happens to our radon levels. And what we found here is these sort of greenish blocks represent those periods of time throughout a normal school day when the building runs as occupied. So we have additional fresh air coming in, the building's running the way it's supposed to from a mechanical standpoint. What we found is that our radon levels within those spaces where we have these continuous radon monitors dropped pretty significantly once the building went occupied. So we were able to acknowledge the fact that the building mechanical system is providing an advantage from a radon control standpoint. We do still actually have an active radon mitigation system in this building. It was the first building where we put in an active radon system. And essentially it consists of depressurization in the building's mechanical tunnel system. But we felt that this was something that we needed to know, and we wanted to be able to relay to people that during those times when the building is occupied, we're seeing the radon levels drop down below that red line there, which is 4 picocuries per liter, all the way down below 1 picocurie per liter, which we felt was extremely significant to be able to relay to those people that are in that space or in those spaces and that have children in those spaces. In regards to, one other quick thing when it comes to radon. Like I say, we have somebody on staff here now that's a primary focus of theirs. We have expanded out. We're going to be doing some additional radon mitigation system installation this summer. We have identified a couple other facilities that we feel would be best suited if we went in and did a little bit of active radon mitigation. So we have a couple of additional systems that will go in this summer. We've also tried to roll in radon management into new construction activities. We have one facility that we're an elementary school. We're putting a gym on this summer. And during construction, we actually designed the facility to have a sub-slab depressurization system as part of the design. That way we can stay ahead of potentially any issues that would ever arise from a radon standpoint. I mentioned earlier a little bit about how we have found that the Energy Savings Plus Health guidance or guideline really helps us from an operation and maintenance standpoint. And to some extent, we sort of consider commissioning and recommissioning as part of our operations and maintenance program because it gives us an awful lot of information about how our facilities are operating. This is a photo here of one of our elementary schools that we did some essentially retro commissioning on last year. This was a facility where we were starting to see some increases in our energy consumption. We were starting to get a few more complaints from building occupants in regards to stuffy rooms or temperatures didn't feel quite right. We had sort of some anecdotal information that indicated that maybe people weren't feeling quite as good as they were at certain times of the day than they had previously been in the building. So we felt that we wanted to go in and we wanted to take a look at exactly what was going on in that facility. So what we did, we retained a local testing and balancing contractor. They came in and went through the entire facility to look at things like airflow rates, to look at, this is a water-to-water geothermal system. So we went in and started looking at flow rates on loop systems, things like that. And what we found was that, like this particular slide here, which addresses priority 18 or HVAC equipment, we had some things that needed to be fixed. We had some fan units where, due to the inherent design, the units literally shook themselves apart, and we weren't providing fresh air the way that we were supposed to be and wanted to be. So we had some mechanical repairs that needed to be made. We found that we had some valve actuators on heat pumps and some valves controlling flow in and out of heat pumps throughout the building that weren't operating as we wanted to see. So based on the information that we were provided with by our balancing contractor, we went in, we made some changes, did some pretty significant repairs on not just this building, but another one last summer as well that we were seeing some of these issues in. And I don't have a slide up here, but I have a little bit of data. This particular facility that the photo was presented of, we ran some quick numbers on this here just this morning to verify. And from the period prior to when we did this work up to the year ending in April, compared to the previous year, we actually saw we had a 33% reduction in both source and site EUI as kBTU per square foot. And also we had about a 33% reduction in total electric costs. This is an all-electric building, no gas service here. So we had a pretty significant efficiency savings on this building. Another building somewhat similar that we did the kind of the same song and dance to, we saw about a 17% reduction on both site and source EUI and total electric costs, which resulted from a financial standpoint. Those renovations or those modifications resulted in a net savings of about $25,000 altogether just within that 1 year period. So this is something where we felt that the guide helped us to sort of identify where we should go next, what we should look for. The other thing, anecdotally, is I have stayed in touch with folks in those buildings, and everybody has commented that they feel that the buildings are more comfortable They feel that the buildings are more fresh. So we definitely saw some positives from the outcome of those changes we made. Really quickly, a few other little O&M things here. I kind of touched on HVAC. Outdoor air ventilation, Kudret alluded to the fact that there are some studies out there now that show that as students and staff are, and office workers, all of us, as we have access to more fresh air, the better we feel, the better we perform. Outdoor air is a big concern for us. We want to make sure that we're providing an adequate fresh air environment for our staff and students. We do a lot of that management through our building management system, which at this point, we have over 90,000 data points constantly pushing and pulling data in and out of our BAS. And CO2 sensors and doing demand control of our building ventilation through those CO2 sensors is a pretty integral part of the way that we address these things. One thing here that I'll just mention is, these are mechanical devices in our building management systems, and things break, things fail, and they do need to be repaired, they do need to be replaced. We periodically go through and simply run a report through our management system on our CO2 sensors, and if we see something that's out of line or kind of out of whack, we make sure that we get out and we get those things addressed as quickly as possible, because we found it doesn't take too long for a lack of fresh air within a space to make people just not feel comfortable and not want to be there to do what they need to do. Again, we're here to educate kids. We want them performing the best that they possibly can. I mentioned, we're really starting to drill down at this point into being able to quantify some things in terms of occupant comfort, some generic health concerns, health-related issues, and this has really gotten the ball rolling for us, and I really think that the guidance has helped us in getting that ball rolling. We've looked at a lot of these things in the past, but we're now, based off of what we know from using this documentation, we're starting to put in place some things that we can use moving forward on a very routine basis, and we'll continue to build this information, we'll continue to evaluate this, and we think that over time, we'll really be able to make some connections for good or for bad, but we'll be able to make some connections between what we're doing from an energy efficiency IAQ standpoint and what we're seeing in the facilities. I alluded to a few little anecdotal things. The guide has also sort of, I don't want to say it's forced us a little bit, but it has encouraged us to have a little bit more communication on a day-to-day standpoint with our buildings. And what we are finding is that as we're implementing these changes and as we're, kind of sticking to that roadmap of what's provided in the guidance, people are responding to us. They're saying that they're feeling better. They're saying that they enjoy being in their spaces more. And that's a positive for us. We're saving money. As a publicly funded institution, that's important because every dollar that we can save on keeping the lights on is a dollar that we can put back into the classroom. We can put into technology for the kids. We can put into, whatever it may be that they need. But anyway, the guidance, if you haven't looked at the guidance, I would really recommend doing so. I think it's a positive thing. We've had fantastic experience with it. It really allows you to be proactive versus reactive. If you can stay ahead of it, you can get ahead of it, identify what your problems are. It's a lot more enjoyable to go in and talk to somebody and be able to let them know that you're trying to make something better for them on the front end rather than come in and have to explain why something went wrong to begin with. So anyway, I'm going to finish up there. I hope I haven't taken too much time, Kudret, but nonetheless, I appreciate the opportunity, and by all means, if there are any questions, we're more than happy to help try and answer those.
Absolutely, Dave, and thank you so much for the great information. We are almost done with the session, actually. Okay, now I have to bow. I would like to show the audience the chat screen before I continue and end the presentation portion. As you can see, the EPA Indoor Air Quality Technical Support Team has been providing you with some links that we discussed throughout our presentation. Feel free to copy those links to download the material that we mentioned. The same chat window should also be used to ask questions to the speakers. So I'll go back to my presentation. EPA is looking for school districts similar to Des Moines Public Schools to test a guide and, if possible, provide us with some feedback on how they use the guide, how it was useful. Are there things that we could do to make the guide more useful to your peers? If you are interested, the amount of time you spend is really up to you. Of course, I know you are already way too busy with your daily work, and please do not consider the use of this guide as an additional time-consuming thing, except when you present for us, of course. But I would really appreciate if you could get in touch with me. My email address is here and at the end of the slide set as well. Feel free to send me an email and we can start the conversations. Here are the two links. The first one is to the guide itself, and the second one is to the Excel checklist generator, customized checklist generator tool. And here is a list of some of the resources we referred to throughout the session. These are provided for your convenience. For example, this is the modern moisture control guidance that EPA has. It's an awesome tool. Please download it. And we have two energy efficiency related tools here on the website, and then the building upgrade manual, which also has a separate K-12 schools section under Chapter 10. And with that, I would like to conclude our presentation and open the floor for questions. Please type the questions into the Q&A, chat box, and someone from our team will collect those, and I'll be reading them slowly. Thank you so much for taking the time. Now I am looking at the questions. There is one question from Carol. She says that many schools are older and do not have air conditioning and proper air filtration in place. My school district is placing portable AC units and air purifiers in individual classrooms of students with respiratory issues. Problem is, these units are not the most energy efficient, lack proper connections to fresh airflow, and some units emit low ozone. As a parent, what is the best way to create buy-in from the district to take these concerns seriously? Dave, since you are an official from a school district, I will pass this question on to you, but I would like to refer Carol to the guide itself. Carol, the guide Appendix 2 is about communications. So I would like you to take a look at the communications section and understand how you might be able to go about communicating the potential issue you're seeing here. And the second portion of the guide I would like to refer you to is the introduction. In there, you will find some great information about one health case and two business case of what you're talking about here. You will find some studies that talk about how indoor air quality could affect student health and student academic achievement. So please take a look at those, and depending on the person you're going to talk within the school district, you may want to go with the business case. Everyone loves dollar savings, right? Or you can go about using the health case and making your case through some of the studies mentioned in the guide. Dave, have you had similar issues, complaints, or situations in your school district? And if so, what would you recommend Carol to do to get some buy-in from the decision makers?
Sure. Well, and actually, I I would reiterate your response there, Kudra. I think that there's some very good information to sort of back up the concern there. Again, both from the business standpoint and the health standpoint. I guess I can only speak so far to our specific experience with this. But I think probably one of the most successful, or the way you can probably be most successful is to provide the facts there, which again, the documentation that Kudra referenced, I think could do a very, very good job at that. It's definitely one of those things where certainly as equipment is properly maintained and as it's utilized appropriately, it can be utilized in such a way that it's not posing a potential concern from a health standpoint, or certainly reduce concerns from a health standpoint. You're absolutely right though, with window type units not being the most efficient. It's a little bit of a tough one, not knowing the situation, and myself not being directly involved with some of the, I guess I would say, the higher level financial decision making. You may be looking at a pretty significant investment to switch to some alternative mechanical type system. But I think that if you utilize the information that's there, present it, from both sides of the fence, both the business side and the health side, and it may also be helpful to find some type of an advocate on whether it's in the form of a consultant, an energy efficiency consultant, an architect, an engineer, somebody that maybe can help better define specifically for the facility or for the district what would be beneficial.
Great, Dave. Thank you. As you reiterated, it all starts with good and open communication between parents, individuals, and district officials. I have some other great questions. Dave, this one comes over to you. Again, Carol asks, in Des Moines Public Schools, what prompted or motivated you to achieve greater energy efficiency, and which key district individuals were some of the champions who pioneered these plans? I think I know the answer, but I would like to hear it from you, Dave.
Sure. Well, I mean, ultimately, we sort of have a saying around here when we look at decisions on whether or not it's the right thing to do. And ultimately what it comes down to, I've alluded to this several times, we're in the business of educating children. And while what we do is sort of behind the scenes, ultimately it comes into play there as well. So what has really been a strong driver for us is if we can operate our buildings more efficiently, if we can do so in such a way that kids are able to better perform, they want to be here, that school becomes sort of a go-to place that's, not just I have to get up and go to school. Everything that we can do to put a little bit more back into the pot that can then be turned around to help provide more from an educational standpoint for these kids. That's the key driving factor. Every dollar, like I said, every dollar we save from an energy standpoint is an energy dollar, or is a dollar that can be spent towards educating children. So that's our first and foremost our key driver. We do have some fantastic champions for our efficiency programs here, and I'll call them out by name. Bill Good, our Chief Operating Officer. Bill came to us in about 2007, 2008. And came in the door really as a strong proponent for both Energy Star and for energy efficiency. He kind of helped get the ball rolling for us. That in turn sort of helped develop a culture. We've had phenomenal buy-in from our facilities management staff. Our board has been phenomenal for us. They've understood exactly what it is that we've wanted to do and why we want to do it. The superintendents that we've been able to work with have been strong proponents of it. I think it's one of those things where you start with one seed, and if that seed's strong enough, it's going to start spreading out from there. And that's been our case here. We've had people that have been able to make the case, show it in black and white, and then thankfully we've had some folks that have been willing to take a little bit of a gamble to see if it's really true. It's been true, and it's just gone like wildfire from there.
Great, Dave. Thank you. And Carol and the audience, I would like to also mention that we have another champion. Dave is also one of those champions in the district. He has been leading a lot of the energy and environment-related activities in the district. So it's really about it's definitely about individual people, but I have been working with this champion team, if you will, at Des Moines for the past decade or so. So David is just being very modest here. All right. Next question, and Dave, it seems like this was directed to you as well. What was the return on investment on the projects being presented? Savings are shown, but not over time and not with investment.
Right. And I'll have to admit to drill down to specific projects that, we have a lot of different variables that go into these projects. I'll sort of speak in small little bits and pieces here. I alluded to the fact that we've done an awful lot with geothermal. We have had some geothermal systems. Tell you what, I'll talk a little bit about the return. I don't have the numbers in front of me to tell you exactly what the initial investment was, but we've had geothermal systems that we have seen the return on investment be anywhere from 4.5 to 6 years, somewhere in there for the installation of a geothermal system. We've had some geothermal systems where the payback has stretched out a little bit more and say the terms of 10 or 11 years. I can speak pretty well about a lot of our lighting projects that we've been doing. Our lighting, interior lighting upgrade projects we've been doing lately. We try and take advantage as much as possible of incentives that are provided by our local utility and utilize those to sort of help cut down that return period. But we routinely see, we can typically go in and relight an entire elementary school, convert it from T8 fluorescence to LED, and we'll typically see a return period on that project of somewhere in the neighborhood of 4.5 to 6 years, and that's assuming, we'll say an average elementary school might have an installed cost of, I'll just throw out $50,000 somewhere in there. But I don't have all those exact figures in front of me. If there's something that somebody is interested in specifically, I'd be happy to discuss that with them.
All right, thank you so much, Dave. I realize that we are out of time, actually. We are over time. So some of the audience still stayed around. Dave, thank you so much for your time. I would like to just make one last comment before we close the session. Someone asked what type of funding you are using to fund these projects, and I would like to refer Rick to your slides. So you don't need to answer it again, Dave. And for the rest of the audience, we will be emailing the slides along with a follow-up email to anyone who registered for this session. Dave, thank you so much for your time and effort. This has been a great presentation. I'm looking forward to seeing more results from your school district, both on energy efficiency and high-quality indoor environmental quality projects. Thank you so much.
Thank you, everyone, for attending today's webinar.